Polynomials are algebraic expressions made up of a sum of multiple terms involving positive integer powers of the same base. So in this example, x squared minus 2x plus 4 is a polynomial with 3 terms. 2x minus 1 is a polynomial with 2 terms. Because polynomials are made up of multiple terms added or subtracted together, if we were to multiply one polynomial by another, the distributive property of multiplication over addition will give us a strategy for how to do so. The multiplication strategy known as FOIL to many algebra students is only the tip of the iceberg in how that distributive property may be applied. In this example, we'll look at how to multiply a binomial, which has 2 terms, by a trinomial, which has 3 terms, and see how FOIL is just the beginning of the story. To multiply a pair of polynomials, the first thing to do may be to remind yourself of what your end goal is going to look like. Specifically, remind yourself of how many terms you'll expect to see in this product. The number of terms you can expect in the product of 2 polynomials is always the product of the number of terms in the first factor by the number of terms in the second factor. So in this example, because I'm multiplying a polynomial of 2 terms by a polynomial of 3 terms, I'm going to expect a total of 6 products that I'm going to have to compute and add together in order to get my answer. I'm going to use a grid down here, whose columns as we go across are the terms of x squared minus 2x plus 4, and whose rows as we go down are the terms of 2x minus 1. And inside each of its cells, we will place the product of that relevant term by its corresponding term. In laying out this structure, I can see why we expect a total of 6 products, because each of the terms from the first factor needs to multiply each of the terms from the second factor before all is said and done. So for example, the 2x from the first factor will have to be multiplied by the x squared from the second factor, forming one of our terms in the product. But that 2x also must be multiplied by the other terms in the second factor, the negative 2x and the positive 4. So now the 2x has been multiplied by each of the 3 terms in its opposite factor. The same must then also be done with the other term in our first factor, negative 1. Negative 1 must be multiplied by x squared, and it must be multiplied by negative 2x, and it must be multiplied by positive 4. So the 6 multiplications that we have to do are now shown inside of our grid. You may or may not choose to draw this grid every time you do one of these problems, but until you gain familiarity and comfort with the material, I recommend it as a good practice. So now we just have to simplify the products that we see inside each of the cells in our little grid. 2x times x squared, adding the exponents on the x's according to our exponent rules, will give us 2x to the power 3. Likewise, 2x times negative 2x is negative 4x squared. 2x times 4 is 8x. Negative 1 times x squared is minus x squared. Negative 1 times negative 2x is positive 2x. And negative 1 times positive 4 is negative 4. Each of our 6 terms having been simplified, it's now a matter of adding those 6 terms together and identifying opportunities to combine like terms. Remember, like terms are terms whose variable factor is identical, having the same variable as well as the same exponent. So in these 6 terms, we find actually 2 pairs of terms which are like to one another. First, the term whose variable factor is x to the power 2 include negative 4x squared and negative x squared. When we add those 2 together, the variable factor x squared remains the same, as always happens with like terms, and what is actually added are the coefficients, negative 4 plus negative 1, giving a new coefficient of negative 5. The other pair of like terms on our grid are the terms having x to the power 1 as their variable factor. those consist of positive 8x and positive 2x, which when we add, keeping the variable factor x the same, has a coefficient given by the sum of the coefficients, positive 8 plus 2, positive 10. So that pair of like terms combines together when added to give us a 10x. The 2x to the third and the negative 4 are by themselves, so we'll carry them through into our final answer. So when multiplying a pair of polynomials together, my advice is to think forward, think ahead of time. How many multiplications am I going to end up having to do in order to compute this product? That number will always be the number of terms from your first factor multiplied by the number of terms from your second factor. Here, we had a polynomial of 2 terms multiplying a polynomial of 3 terms, so we expected right off the bat that we would do 6 multiplications. Keeping track of those multiplications in a little grid helped us to make sure we didn't miss any. And after multiplying all 6 of our products, we could then add all 6 of those terms together and combine those of them that were like terms with one another to get our simplified answer.